Sorry, the last video got cut short, but it's really hard to make a video in under 15 minutes. I can't upload them if they're not that short. So let's start doing this problem, and this time I'm going to write it in the form a sub n equals a sub 0 plus nd. D is obviously a 7. N is going to be an 11 this time. And our a sub n number is going to be the 50, or a sub 11. Plug in everything you know. 50 equals a sub 0, which you don't know, plus 11 times 7. That's 77, so subtract it. And you get negative 27 would be the a sub 0 term. But if you have to start writing the first three terms of the sequence, you need a sub 1, which would be adding another 7 to that, which is negative 20. A sub 2, add another 7. And a sub 3, add another 7. That's another way to write the first three terms of the sequence. And then also just finishing what the rule should look like without parentheses this time. A sub n equals negative 27 plus n times d, and always leave the n as the variable. It looks better to put the d of 7 before it, so 7n. Okay, the last two problems where we're practicing applications of arithmetic sequences is down here. Two terms are given and we have to write the rule. All you know right now is that in this first information, n is a 7, but a sub n is a 17, and over here n is a 10, a sub n is a 29. Those are fairly close together, where I could kind of think about how if I wrote the numbers in between them and just give them a visual look like this, I can start thinking about what it might take to get from one to the next with even these skips. So again, this is a sub 7 and this is a sub 10. What I usually find is the common difference in between every number, but I'm kind of stuck with just having to take 29 minus 17 to find what that total distance is. That's 12. And if it took 3 skips to get there by multiplying something, then you can divide it by 3 to get back to a 4 for your common difference. Let's test this out. So if I go plus 4, that's 21, plus another 4, that's 25, plus another 4, you get the 29. So you want to just double check that it works. So now I can use this to write the rule, and I can just pick one of these sets. Don't intermix the wrong n with the wrong value of the term. Always keep, n equals 7 with your a sub 7 value. So I'm going to write the rule with parentheses this time. A sub 1, which I don't know yet. Oops, so I'm going to go back and fill in a 17 back here. I don't know a sub 1, it's the one I leave alone, plus the common difference of 4 times n minus 1, which I can plug in 7. And now I just do this math. 7 minus 1 is a 6. 4 times 6 is 24. So I'm subtracting 24 from both sides and getting that a sub 1 is a negative 7. Now I can finish writing the rule. Go back to an a sub n. It would equal negative 7 plus the common difference of 4 times n minus 1. So the key points here were to subtract the values first and then divide, but the number that you divide by is how many skips or jumps it takes to get to the next term. And in other words, 10th term minus 7th term is another way to quickly get that 3. We'll use those shortcuts over here on the other problem, and this time I'm going to write the rule with no parentheses. So first I'm going to go the value 26 minus the value 71, and it's okay that we're getting negatives, but I need a calculator. Is negative 45. I need to divide that by a certain number, but this is where you use your 7 and your 16. How far apart they are is the right number to divide by. And so we get the common difference is negative 5. Now I'll just use both of these numbers, n equals 7 and a sub n temporarily is 71 with a difference of negative 5 to start writing my formula. A sub n equals a sub 0 plus nd this time. I'll just write with the numbers kind of filled in below it this time. 71 equals a sub 0, we don't know, plus 7 times negative 5. That's a negative 35, so I need to add 35 to both sides. And 71 plus 35 is 106. The final rule gets written as a sub n equals 106 plus n times d. N I leave as a variable, so I want to go actually minus 5n. Sometimes your numbers are going to be really big. Sometimes you could even get decimals, which we haven't hit any yet. The last concept is, what is a series? And series, oh, I guess I meant for it to be, what is in your notes? An arithmetic sequence. I'm jumping ahead too much. Gives the rule for a pattern that you can find for any term. I guess I'm just reiterating, what do those two rules look like? You can pick either one that you like. Okay, expanded form of a sequence. Make sure you use commas. So, whatever sequence I want to think of, even the Fibonacci sequence real quick, it has to be separated by commas and ended in dot, dot, dot if it goes on forever. The expanded form of a series, though, is going to be separated by addition. I could even add some of the numbers in the Fibonacci sequence if I was told to, but I put plus in between those. And I would need a stopping point somewhere because I can't just keep adding numbers forever. And so, if then I needed a calculator to type this in, 2 plus 2 is 4, plus 3 is 7, plus 5 is 12. Maybe those first 5 numbers of the Fibonacci sequence have a sum of 12. So expanded form means you write out everything in the sequence or series, but then whether you separate with commas or with plus signs depends on which it is. The next new thing we're going to talk about is summation form, which means to use this big Greek letter, and it is sigma, which in the Greek alphabet is capital S, and it's going to have 3 parts to it. It's going to have a number to start with down here, and usually the variable that we use is an I, an N, or a K. Those are really common, and you can pick whichever one you like. There will be a number up here that will be N, how many numbers you want in your series. And then in here needs to be the rule, like, are you doubling it and adding 1, or are you taking it times 5 and subtracting 3? So when you get asked to write in summation form, you're just filling in these missing numbers on that sigma notation. So what is this again? They are called series. It's an expression. So an expression is like write them all out and get an answer if you need to for adding the first n terms of a sequence. And the formula for an arithmetic series is this. We're going to just plug numbers in. S sub n stands for the sum that you're going to find. N is how many numbers you added. A sub 1, of course, is your first term in the sequence. And A sub n is the last term in the sequence that you're adding. So practicing it over here in this form of summation form, n is a 20, and I have a rule that I'm going to follow, but I can't really fill in everything on this formula. And again, it's n times a sub 1 plus a sub n divided by 2. This is kind of like the movie theater problem where you take how many are in the first row plus how many are in the last row, average them, which is like adding and dividing by 2, then take it times how many rows, and that's our n. Now, as I start to fill in some of this stuff, I realize I need a sub 1. What do? I plug in a 1 to my rule. And so I take 3 times 1 plus 7 to get 10. So I'm going to go ahead and erase this and put in a 10, but I'm going to make it stand out where I'm filling everything in. Now I need a sub n, which is really a sub 20. The way I find it is I just get to plug a 20 in for n. That's 67, so it goes here. And n is just 20. Follow the order of operations or get it typed in your calculator as one single expression. This is going to be 77. So now it becomes 20 times 77 over 2, and it really doesn't matter where that 2 is at. So if I even do that and make my fraction bar longer, I can cross simplify and turn that into a 10 over 1. And now it's easy for me to just take 10 times 77 and get a sum of 770. I'm going to skip to the last one because I only have a few minutes left before this video is too long. This time, it's find the sum. So I'm still going to use this formula right up above here, but I'm also going to practice writing an expanded form one more time with you. I need to be able to find a sub 1 and a sub 6 if I'm going to be able to fill in, and I already know that n equals a 6, that top number on the sigma. When I find a sub 1, I have to take -4 minus 2 times 1. I'm plugging that in. That's -4 minus 2, which is -6. Plug in a 6 for your last term and get -4 minus 12, which is -16. Plug everything into your formula. S sub n equals the number of terms times the first one and its value, not a 1 and not a 6, but their values, -6 plus -16, the last term, averaged together. And I can do this by hand too, because I can add these two negative numbers up and they are an even, so I get -22. And then I can go 6 times -22 over 2, and now I can simplify those down to a -11. And 6 times -11 is a sum of -66. Sometimes your numbers are going to add up to a big negative sum. Expanded form would look like this, though. Start with a sub 1 and write pluses in between because expanded form of series means they're pluses. And then start just subtracting 2, which is your D number here. So then it would be -8 plus a -10 plus a -12 plus a -14 plus a -16. And you can see by the 6th term, I ended on the right number. And that concludes the notes. So good luck. I could have also written that with minuses in between.